As we close out our time looking at one-sample means inferential statistics techniques, I thought it might be a good idea to make some comments on comparing and contrasting one-sample means confidence intervals versus one-sample means hypothesis tests. So as we start to compare one-sample means confidence intervals and hypothesis tests, we first of all note that for confidence intervals, what we are trying to do is construct an interval estimate of a population mean. In contrast with that, for our hypothesis test, we are always testing or evaluating a statement, namely the null hypothesis, regarding a population mean. Secondly, the sample mean for a confidence interval is the key value that we use throughout for all calculations. In contrast with that, for a hypothesis test, we use the null hypothesis mean value as the key value for all calculations throughout. As far as comparing sketches for a confidence interval, the sketch illustrates the actual confidence interval itself as the shaded portion. In contrast with that, the shaded tail areas for a hypothesis test sketch illustrate the p or probability value. And then lastly, for both confidence intervals and hypothesis tests, we run a four-step process. In the case of confidence interval, we do it to construct the interval. In the case of the hypothesis test, we do so to test the null hypothesis. Continuing to compare the two inferential statistics techniques to each other, we note that for confidence intervals, the construction of the interval is based on a particular confidence level. In contrast with that, for hypothesis tests, evaluation of the null hypothesis is based on a particular significance level. Next, we note that for a hypothesis test, the prepare step additionally requires identification of the parameter of interest, that is the mean, and listing hypotheses. That, of course, would not be included for a confidence interval. The next thing we take a look at in comparing is that for confidence intervals, we require a t asterisk value, which is found using our guru, and that is the basis for identifying the interval endpoints on the sketch. In contrast with that, for a hypothesis test, we find what is called the capital T or test statistic value, and that is used as the basis for identifying tail areas on the sketch. We find the capital T value with a formula, and then we use that and our guru to calculate the p or probability value. The last thing I want to note in comparing these two inferential statistics techniques for one sample means is that for confidence intervals, the conclude step consists of a statement interpreting the confidence interval in the context of the problem, whereas for hypothesis tests, the conclude step consists of two separate things, each of which requires a statement to be written down on paper when you perform it. First, you need to have an evaluation of the hypothesis test by comparing the p or probability value to alpha, and the result of that would be either that you reject or fail to reject the null hypothesis, which is what's being evaluated. And then secondly, you would need a resulting statement providing a conclusion in the context of the problem based on the evaluation of the null hypothesis that you did in the first step. One final thought. Keep in mind that with hypothesis tests, unlike with confidence intervals, it is possible for t-scores to exceed the limits of the t-axis scaling that you have put down on your paper. In other words, outside of the range of -4 to 4. And therefore your sketch may require a break on the axes to accommodate the larger t values. And that concludes this presentation.